Okay, welcome back Year 10s. This will be one of the final videos that I'll get you to watch for this topic. I may make a couple more actually. I was thinking maybe just a couple more going through some of the more challenging questions, but they will be optional for you. So this is the last one that I'd like you to watch, and I do thank you for taking the time to do that. As you can see, what we're going to do in this video is look at something called rationalizing the denominator. So I wanted to first explain what that is and why that would be necessary. So if you have a look at this first little expression that I've got here, 4 on root 3 plus root 3 on 2, you'll see that there is a square root, or there's a surd in the denominator. Now this is a problem because if I needed to say check for like surds, I wanted to collect those like surds, it becomes very challenging when you have a surd in the denominator. Now, luckily, there is a way that we can deal with this. So there is a way to get around this, and that's what we're going to be doing in this video. Now, there's a few different ways, there's a few different techniques, in fact. The first couple I'm going to show you is the nice and straightforward rationalizing of the denominator, when you've just got one surd on the bottom, like you have over here with the root 3. But I also want to show you what you do when there are two terms on your denominator, because it's a slightly different process. So what do we do about this surd on the bottom? We will do a little bit of manipulation so that the surd will actually appear, well, with what we're going to do, we will get a surd as our numerator, but that's okay. And hopefully, if we've done it right, we'll get the whole number or an integer as the denominator. So I'll show you what I mean by this. If I just go to my next slide. We will be multiplying by a fraction, but what we'll be doing is we'll be multiplying a fraction that looks similar. Well, here's an example down here. The reason we're going to do that is this fraction, as you can see, when I multiply that, that's the equivalent of 1. So root 2 on root 2 is the same as multiplying by 1. And when you multiply by 1, you're not changing the value of your fractions, because we don't want to change the actual expression itself. We don't want to change the value of it, because then obviously the mathematics of what we're doing is not correct. So what we want to do is make sure whenever we are rationalizing, whatever we multiply by, that we do make sure that we've got a numerator and denominator that's identical, so that we aren't actually changing the fractions themselves. So when we do this, we are going to be creating what's called an equivalent fraction. So it is the value of it is the same, but it may not look the same. So I'll show you what I mean. A nice easy one to begin with, 1 on root 2. Now we don't want this root 2 as the denominator. Like I said, it makes things really difficult, in fact, for us to then simplify. It's going to be a lot easier if we have, or if we can try and remove that root 2 from the denominator. So the reason it's called rationalizing, as you can see, is our root 2 on the denominator is irrational. So we want to rationalize that denominator. Just thought I would make that clear of why this video is called what it is. So this next one, this next step, I don't like this root 2 on the bottom, so I'm going to multiply top and bottom. So I've got this whole fraction here, root 2 on root 2 on root 2. Multiplying by that, what I'm going to get will be root 2 multiplied by root 2 is 2. So it's actually going to look like this. So I mentioned before, they may not look the same, but they are the equivalent. So 1 on root 2 is the equivalent to root 2 on 2. Okay, so obviously that one's nice and easy, but we want to see some more challenging ones. Here we go. First of all, when you come across one, you need to decide, okay, what am I actually multiplying by here? What's the issue? Well, the issue here is the root 5 that's on the bottom of this fraction in the denominator. So what I can do is multiply top and bottom by root 5. So this is 2 root 5 on top. On the bottom here, we have 3 by 5, like so. Reason, of course, is that root 5 by root 5 is 5. So I've just multiplied the numerator out and then the denominator out. Sometimes, of course, you might have a couple of different terms, on your numerator. So it might look a little bit different then. So I'll show you what we do here. Again, the issue is the root 10. I'm not concerned about the root 2 because, like I said, it's okay if there's a surd in the numerator. What we don't want is it as the denominator. And in my next example, you'll see why. You'll see how we simplify once we do have a rational denominator. This one here, however, I want to multiply by root 10. So I'm going to go, actually, I'm just going to erase that because I'm going to put the root 10. Oh, no. I'll change my mind. I'll do it like this to begin with. I don't need to multiply by 3 root 10. Just root 10 is enough because what I need is just that root 10 there to multiply by another root 10 to cancel out that surd, in effect. Now, what I will do here is just be careful. I've got this whole expression 6 root 2 plus 1 multiplied by root 10. So this is where brackets are essential. So like so. You can fix up the bottom now if you like. So that'll be 3 by 10. And we'll do the top now. So this is going to be 6, 10 by 2 is 20. And this is just multiplied by 1. So we're just adding on root 10 on the end there. That's on 30. And then do make sure if you can simplify, of course, that you do that because we can see here this is 4 by 5. So that is 6 by root 4 by root 5. So 6 by 2, like so. If we had like surds here, I'd also add them together as well. Okay. One other thing that I'd like to show you, it does go across a couple of slides, but I'll just go to the next one. With this one, I'm going to show you once we do cancel out the surd, or I shouldn't really use that term, once we do rationalise the denominators here, it might be possible then to simplify further. So with this one here, we've actually got 2 separate rationalising of the denominators we're going to have to undertake. So I'll show you what I mean. First of all, this term here, I'm going to have to multiply like so, because I don't want this root 7 on the bottom here. But of course, I need to do something different with this term because that's root 5. Like so. Okay, so this will simplify to 4 root 7. This is just 7. This is 2 root 5 on 5. Now I've just made a note on the side just so you know what I'm going to do now. We've got 2 fractions here, one with the denominator of 7 and one with the denominator of 5. So just going back to your fraction work from quite a few years ago now, or actually no, last year you would have done quite a few fractions, I'm sure. We need a common denominator. So I will multiply top and bottom by 5. And this top and bottom by 7. Now you don't need to put this in your workings. I'm just doing that to show you what or how I'm going about it. Just move that over so I can get my colour back. Okay, so we're going to have 20 root 7 on 35. Here we're going to have 14 root 5 on 35. Now we can add the numerator together because we have common denominator. So we have 34 root 7, As you can see, I just made a mistake. We don't have a common surd, so I can't add them together. So 20 root 7 plus 14 root 5 over 35. That's better. Okay, I'll leave that as is, and now what I'm going to do is show you maybe the hardest part of the topic, so just bear with me. what we can do when we have two terms on the bottom. So I was showing you before just a few different examples of varying complexity, I guess. With these ones here, we actually need to do a little trick. Now, the reason I've said here, recall this particular identity, difference of two squares, is I'm going to use that to do, like I said, a little trick. I think it's quite nifty, to eliminate what I've got on the bottom here, which is a root 3 minus root 2. Now, of course, I can't just go ahead and multiply, say, by root 3 on root 3, like this, because that's not going to deal with the root 2 here. All I'm going to do there is get a root 6. So I'm not eliminating the surds. So we do need to be a little bit more crafty with binomial denominators. So when we've got two terms on the bottom here, or two surds on the bottom there. So I'll do one that's really, really basic to start off with so you can see what's going to happen here. Now recall the difference of two squares, because what I'm going to do here, see how I've got here root 3 minus root 2? I'm actually going to multiply top and bottom by root 3 plus root 2. And the reason I'm going to do that is if you have a look at the denominator here now, I've got root 3 minus root 2, so we'll just call it a minus b, and on this side, a plus b. Now, I know when I expand that out, I'm going to get, it is the difference of two squares, so I'm going to get a squared minus b squared. And what happens when I square a surd is that I will be able to eliminate that square root sign. I'm going to get an integer. And that's exactly the whole purpose of rationalizing the denominator, is to aim to get an integer on your denominator. So to finish this off, on the top here, I'm going to be left with root 3 plus root 2. On the bottom, I'm going to have root 3 by root 3 is 3. Sorry, I might do it the long way, sorry. Root 3 squared is what I'm doing, minus root 2 all squared. Sorry, I don't want to skip any steps because I don't want to confuse. I'm going to commit a crime here. I'm going to go sideways because I've run out of space at the bottom here. I'm going to be left with root 3 plus root 2. And here we're just going to have 3 minus 2. And that's just 1. So I'm actually going to leave it like that. I'm not going to bother putting over 1. As you know, we don't do that. So I'm left with root 3 plus root 2. So, of course, that, like I said, was a nice and simple one. I'm going to do one more, and I'm going to show you how tricky they can get. Well, not tricky, because the maths that we're doing here is pretty straightforward, but there's just a lot going on. So I'll show you what I mean. All right, so here's one here. I'm probably going to use a fair bit of space here. Just go nice and slow and pause if you need to. All right, so my aim is to use the difference of two squares. At the moment, I've got 3 root 2 plus 2 root 3. So what I'm going to do, and to save on space, I'm going to start from this first bit. I'm going to multiply by 3 root 2 minus 2 root 3. Now, you don't have to change colours all the time like I do. I just go a little bit crazy because I've got so many on offer. I'll just go back to my standard white, I think. Okay, so 3 root 2 minus, make sure you've got top and bottom the same. Otherwise, you're changing the fraction, and that's not allowed. Have a check on the bottom. Check that, I've got difference of two squares there. So a plus b, a minus b. So now I will start to expand this out, or multiply it out, I should say. On the top here, I've got, I'll just put it out in the form that you would be used to, and that's with your two brackets. So you see we've got a binomial expansion here, two brackets here. This is not a special identity because it's not in the form a plus b, a minus b, so I can't do it the nice speedy way. This bottom bit, however, I can because it is difference of two squares. So I'm going to have 3 root 2, so a squared, minus b squared, so minus 2 root 3 squared. Okay. Hopefully you're still with me. Next bit, I'm going to expand this bracket. So first term by second bracket, second term by second bracket. I know that a lot of you really like using your FOIL, so this is going to come out as FOIL as well. This is just my preferred method. Seeing as we are rewriting the last that denominator now, we may as well simplify it now. So this is 3 squared by root 2 squared. So that's going to be 9 by 2, so that's 18. This is 2 squared by root 3 squared, so that's going to be 4 by 3. Like so. Okay, we're nearly there. Let's do this top line. That's going to be 3 by root 2 minus 2 by root 3 by root 3. So that's 2 by 3, so that's 6. Plus 3 by root 2 by root 2, which is 2. 3 2's 6. And finally, minus 2 root 2 by root 3. So 2 root 6. That's all over 6. Just simplified the denominator from above, and this comes out really nice at the end because our negative 6 plus 6, that's cancelled out. 3 root 6 minus 2 root 6 is just root 6 on 6. Lovely. Okay, so like I said, there will be a lot going on here, but I just want you to take it really, really slowly to begin with, and do stop if you are if you're getting confused, if you're getting muddled, and just ask for a little bit of help because there's nothing wrong with that. Okay, I'll see you in class. We'll practice this, and then we are done for this topic, and it'll be time to revise. So thanks again, Year 10s.